So for today, we will build a dashboard to control a robot arm, as Sanjeev already introduced. A dashboard like this one that I'm showing here. So what do we have here? This is we are assuming that we have a robot arm that is running somewhere, that is its own physical entity, and with this dashboard we are able to control its movement. In this case, we are just controlling its angle, so we send messages to the arm and we get back its angular position as well as its velocity. So if I turn this dashboard on, using these controls, I'm able to set a target angle, and with these controls here, I would be able to also to control the PID controller for the arm, so that it's able to match the target angle that I have set. Okay, as you can see, this is a dashboard that is running in real time, so the arm is constantly sending us updates about its positioning, and we are also sending commands to the arm. So let's get started with this. Let me stop the dashboard for now and open VS Code. Now, Genie Builder is an extension for the VS Code editor. Okay, you can find it in the VS Code Marketplace here in the Extensions tab. And after you install it, if you go back to the Explorer tab, you will have a new tab called Genie. In this tab, you will see the list of applications that are being managed by Genie Builder. In this case, I already have a few that are stopped, and the current one that is already running. Yeah, you can easily create new ones, load existing apps from the file system, and so on. And then here on the top left, what we have is the File Explorer, where we have the files corresponding to each one of the applications. In this case, we will focus on here on this folder that contains the robot arm files. Now, when it comes to creating a Genie application, the workflow is quite simple. You start with some data analysis code, with some existing data that you have beforehand, and you bring this data or code into Genie Builder and create the interface around it. In the case of this application, what we have for starters is a module that implements our robot arm controller. We have dropped this module here in the sleep folder, and it will be readily available for us to use in our application, as I will show. Just to give us an introduction about how this robot arm controller is implemented, let me show you first the diagram. That's right here. Okay, so this is our starting point. What we have is a control module that implements this diagram. So we have a PID controller that sends a control signal to our arm, and then the arm, using a position sensor, we get its actual angular position and feed it back to the controller. Using this feedback, the controller will update its control signal in order to make the arm match our desired position. Okay, so we have just one input that would be the desired position for the PID controller, and then, as you saw in the dashboard, we have additional controls for this control element. So now let me show you a quick overview in the code of how this was implemented. We have some structs and functions to implement the feedback loop of updating the control signals and making the robot arm move. But what's most important is this function that we have here. By the way, all of this code is available online. Okay, let me just show you real quick in case you want to take a look. It's at github.com build-with-Genie in the robot arm control repository. Okay, so if you go here, you can download this already built. So going back to our code for the robot arm controller, we have this function that it is the function that will simulate the arm entity that is running in a separate process. Okay, so this process will take as parameters two communication channels, one input channel and then an output channel, so that the arm receives and sends messages via a channel. And once we run this function, we will simply instantiate a PID controller with some initial parameters, then the arm with some fixed parameters, set some initial target angle, time, and the time differential, that is how often the PID controller and the arm update the position. Then after this initial declaration, we run a loop that runs continuously, that is forever. And inside of this loop, at each iteration, we do the following. We check the communication channel for the new messages. Okay, if there's any message that has been sent from the outside to the arm that's running, we will take it, and depending on the action that it asks, depending on the action, we will do something. So in this case, we can have two kinds of actions. One of them to set the target angle, so we just set the variable target angle to whatever was filled inside of the channel. And then the other case, we have the PID control parameters. Again, we will read from the channel the PID parameters and assign them to the PID controller. Okay. After checking the input channel, we do the actual update of the arm position. So in this case, we will just calculate the error signal and then the control signal and update the arm position. Okay. Every time we run this loop, we will also send through the output channel some metrics. In this case, we have the current time of the arm, the current angle, its velocity, the reference that was sent to the PID controller, as well as the error measurement. Okay. Note that we assume that both the input and output channels can only contain one sample. So in this case, before we write to the output channel, we take from it in case there was something already there, and we just write. I mean, we do this with just one sample, so to simulate a real-time running signal. Okay, and this would be it for the process that's running the arm. Now, once we have this initial code, that would be our starting point, we can start building our Genie app. For this, we just need two files, one of them called app.j.html, which will implement the visual interface. We don't edit this file manually, we do it with the visual editor. And then on the other hand, we have this app.jl file, which is the main entry point to our application. Okay, this is the file that implements all of the logic, handling the interactivity of the app. And this is where we will do our initial setup. Here, at the beginning, we are setting an environment variable for the following reason. Since we have we're simulating a robot arm, so that we have a single physical entity, what we want is that anyone accessing this dashboard from different browsers or computers, everyone sees the same information. Typically, a Genie application, each user will have its own instance of the app, let's say. So they will all be able to deal with their own data or see their own plots and so on. But in this case, since we have a single arm and we want to send comments to the same arm, everyone needs to be using the same channel. So we just set this environment variable, and everyone that accesses the application at the URL will be accessing this channel. Then we simply import the Genie framework packages, import the module. Okay, notice that we are just doing the calling using. We don't need to include, since it's already made available by dropping it into the lib folder. And then we do some initial configuration to set some parameters. And after that, we declare the communication channels, an input channel and an output channel that it will take dictionaries as its communication medium. And after that, we just run the ARM process. In this case, we call the run ARM function that I explained before with the input channels, and this will start the ARM process in the background, since we are running it an asynchronous task. Okay, and then we can use these channels to communicate with this ARM process. So now that we have this initial setup, notice that since I'm already running the app, this is already running. Okay, so we have this initial setup. Afterwards, we will implement the reactive code, but that will come at a later point. The next step would be to implement the visual interface, that is the user interface. And to do this, we will open the visual editor by clicking here on this eye icon. And this will open the canvas of Genie Builder. Here we see the canvas where we are building the interface, where we will drop components to build the interface. And to the right, we have several panels. And the most important of them is this library panel, where we can see the list of components that we can use to build our interface. We have elements for setting things like the layout, text elements, other components for arranging content like tabs or pop-ups, as well as interactive components like knobs, radios, sliders, tables, and a long list of charts to pick from, as well as other useful components like the uploader. Then there's also other tabs that I will explain as I use it. So now that we have this initial setup of our logic, we have loaded our module, we can proceed with the UI design. So let me collapse this. And in this case, our UI is going to be quite simple. We just need to add some controls and a couple of charts. Here I already have some initial layout in order to speed things up. But yeah, let me just start adding elements. So for the controls, we will require a toggle in order to enable and disable the dashboard. Also, a knob to set the angle. And we'll add also a header here to separate for the PID controls. And now we will add the controllers for the PID. Let's add field labels. And also a set of sliders. I can easily duplicate these elements by clicking on this copy icon. So let me rearrange this. Okay. So now that we have this, also let me, since we will require this, in order to center these two components here, I will put them inside of a container. As you will see later on, this will help us keep everything in the center. And another container for the toggle. Okay, as you can see, it's already centered. So we have added our initial set of controls. The next step would be to add the charts. We will add just 2 line charts here and another one here. Okay, so we have our initial UI set up. Let's preview it by clicking here on this monitor icon. And let me make it this a little bit bigger. And yes, you can see our UI is mostly more or less implemented. Of course, nothing is working yet because we have not added any interactivity or any reactive code. But yeah, it looks more or less like the one I showed you in the beginning. So the next step would be to proceed with some configuration, some preliminary configuration of the components. Okay, so for this, let's, for instance, this toggle, when we select each element on the canvas, this will open its properties here in the right sidebar. Here we can see its main properties. Then we have a list of suggested properties that we can add and easily remove, as well as an even longer list to choose from, so that you can see these components are quite configurable. So let's proceed with the initial configuration. For the toggle, we will set its label to dashboard on. Notice this data binding field. I will leave it for now, as I will go into that in a moment. Then for the knob, since this is an angle controller, so we want to set its maximum value to 2 pi, so we will set it to 6.6 and the minimum value to 0. So well as okay. And then for the sliders, again, we will set its maximum value to 1, minimum to 0, and the step size to 0.1. In this case, let me just duplicate this one. Oh. Okay, apparently, let me just do it the other way then. 0, 0.1, as well as oh, sorry, 1. Okay, now we also want to add some some additional field in order to disable the controls when the dashboard is turned off. So let me add this disable field, okay, that lets us, at the moment I will leave it as off, but later on I will configure it with a variable that we can use to toggle this property. So I will allow that here. Okay, so now we do have some preliminary configuration. Let me add also the headers for the, oops, okay. No, this is shown. Okay. I can edit the headers right here. So this would be the integral, the proportional, and the derivative parameters. Okay, so we have the initial configuration of all of the components. The next step would be to add some styling. Since this is already quite well styled, let me show you how one would do that. We have two options. One of them is the new theme editor that we have added in the latest release. That lets you switch between themes. In this case, we have a dark theme or a default light theme. You can also customize them by clicking on this customize button, and here you can set things like this: main colors, backgrounds, text settings, and so on. For instance, let me show you how one would change the background of the app. And once you are done with the styling, you can save the changes, and this will create a new theme file that you can find here in this public folder here in the CSS themes, theme.css, and this can be copied over to other applications. Then another option will be to use the styles tab that lets you select any component on the canvas and set its style properties. This will be any kind of CSS property that you can think of, as well as CSS classes that you might have defined in the CSS file. For instance, here for this column, let me show you how you can change the width, and this will give you feedback in real time. Also, let me see if we enable the send. Oh, apparently I set it to the default. Okay. I was checking the styles to make sure that everything is centered. Okay, so we have set that line to center. Okay, so we are done with the styling and the initial configuration of the app. And so the next step would be to enable this dashboard, okay, to configure each component so that it holds data and that it responds to user interaction. In order to do that, what we need to do is for each one of the elements, of the interactive elements, we need to declare a series of reactive variables in the Julia backend. That is, this would be the state variables that will hold the state of the component. Okay, so in order to do this, we go back to the app.jl file and start defining our reactive variables in this block delimited by this app macro. Now, a reactive variable is a variable that exists both in the backend and also in the browser, and they are synchronized two ways. So if its value changes on one end, it will be automatically updated on the other end. So our way to declare these reactive variables is with this. Well, one of them is with the in macro that denotes that this value is sent from the browser to the Julia code. Okay, so once we have declared one of these variables, this will be automatically present in the browser. So we start by declaring the variables for the PID controller and the angle input with the angle variable and the 3 parameters for the PID. Notice that we are initializing these values to their corresponding type so that we can later on update them without errors. And then for the dashboard controls, okay, we will like to have a variable to enable or disable the dashboard, then an output variable to disable the controls. Okay, that is the one that we will use to disable the individual controls. Here, notice that we are just setting this to out. We are taking it without, since we are not taking any inputs from the dashboard. We are just sending a value to the browser. This is a configuration value in case we wanted to use it, but we will not be using it in our case. But this is for the maximum number of data points we wanted to have for the charts. Another variable for the process that's going to be continuously polling the arm. I will explain this in due time. Okay. Again, this other variable is for the refresh rate of our dashboard. That is how often we are going to update the charts, and another variable to trigger the running of this polling task for the arm. And then we just declare 3 arrays that we will output to the UI with the contents of the data that we want to plot. Okay, so now that we have this initial variable definitions, you can see that they are appearing here in this bindings panel, and we can click on the definition here, and we will be directed right to its line where they were defined. This is very handy when you are doing bindings, when you are in the UI, and you don't remember what exactly variable was doing, so you can click here, and you will be directed right here. So what we need to do is we have all of these variables already defined. Just go over each one of the components and bind them to their corresponding state variable. So for this dashboard enabler, we will click on this lightning icon and bind it to the dashboard on control. Then for the knob, again, this will be for the angle. This slider will be the KI, KP, and KD. Okay, and this will be it for the initial controls. Now next would be configuring the charts. Okay, sorry, yeah, that's all. While I'm at it, let me bind each element to the controls. Okay, so when this variable is true, these elements will be disabled. Okay, so in order so that we are not able to send commands to the arm whenever the dashboard is disabled. So after we have configured the initial controllers, let's do the plots as well. If we click on one of the charts, we see here to the right, it's a properties panel with this configurator that lets us switch between different types of charts, as well as configure many of its properties. In this case, we will put it back to a line chart, but you can see that with this you can do pretty thorough configuration of your charts. So in this case, what we need to do is just pick some data to bind to the X and Y axis of the chart. In this case, for this top chart, it will be the angle. So we will set the X to the time vector and the Y to the angle. No, sorry, it would be angles, plural. Okay, we would be able to add multiple traces, as well as configure some of its properties, and let me do that now. Like let's set the title for the angle and add other properties like the margins so that it looks a little nicer. Okay, here we will set the left margin to 30 and the top margin to 30 as well. Okay, and let's do the same for this bottom chart that we will use for the velocity. And here, okay, so let's bind data here. The X would be the times and the Y would be the velocity. Okay, and again, let's set some layout properties like the margins, and also in this case the height, since we want to make this a little bit smaller. Set height to 150 and the margin left to 30 and 30. And with this, we do have our user interface finished in terms of configuration and bindings. We have bound everything to its corresponding reactive variables, and now what's left to do is make these variables hold some data, because as it is now, they are all initialized to some initial values, and what we need to do is fill them with actual data. And to do this, we will start defining reactive handlers. Okay, a reactive handler is implemented with this onChange macro, and what it does is it will watch a list of reactive variables, and when the value of this variable changes, either because we have modified it in the Julia code or we have modified it in the browser in the case of these input variables, when this value changes, it will run a snippet of code. Okay, so we need a series of reactive handlers in order to communicate with the ARM. Our first handler will be simply one that watches the angle that's bound to the knob, and when we select a new angle, we will send a new message to the ARM, a new command that's going to be set target to specific angle value. Right, then we will need another handler to watch the variables for the setting the PID controller. And again, whenever we move one of the sliders, this handle will be triggered, and we just send a new message via this channel. In this case, it would be set PID, and we will send a tuple of multiple values. Okay, and the ARM will automatically receive this value and update it. Now, these are the first two handlers, and the next one we will add is the one to enable the dashboard. Okay. Inside of this handler, we will watch the dashboard on variable that's bound to the enable dashboard toggle, and in here, if we want to turn the dashboard on, we will run a series of code lines. Essentially, what we are going to do is we are going to clear the data that's displayed on the plots, and we will read from the robot arm latest message in order to initialize the x-axis of the chart. Okay, and then we will enable the controls. Okay, so we will set the controls of variable to false and trigger the task that will poll the robot arm, okay, by setting this variable to true, which I will show in a moment what this actually means. Okay, if we want to set disable the dashboard when we move the toggle to false, then we will land here and we will just disable the controls. So let me just show you how this actually works. Okay, let's preview this in the browser, so in the preview window, and as you can see now the controls are disabled, but when I click here the controls are suddenly enabled. And we can also see that we are actually, since we have these handlers already defined here that are sending messages to the ARM, we can see, because we have added some logging to the ARM that's running, yeah, we can see here that we are sending some messages, and we have here the debug information anytime we interact with the controls. So we see that this is working. So what's only left to do is constantly watch the output of the ARM in order to fill in these plots. So what we will do is, as I said, we will do this in a separate handler. Okay, we use this one to enable the dashboard, and then from this one we will change the value of a reactive variable, and this reactive variable is going to be watched by this big handler that we have here. Oops. Okay. Inside of this handler, we implement the code responsible for constantly checking on the output of the ARM and updating the arrays with the data that's going to be plotted. So this is a quite simple process. While we have the dashboard enabled, okay, what we will do is read the output channel, and then we have a number of maximum data points that we want to show on the chart. Okay, so once we reach this maximum, you will see as the chart is starts sliding to the left. Okay, so in this case we are at the maximum. We'll just pop the first value and add a new one at the end. But essentially, we read the output from the ARM in this loop, and then we simply append these values to the arrays that we are going to use for the plots. Okay, so we read the time value, the current angle of the ARM, as well as its velocity, and we append this to the arrays. Notice that I'm assigning with this assignment, every time we make this assignment here in this loop, the arrays will be updated, and this update will be sent to the browser. So the chart will be instantly updated. Now, since this is running an asynchronous process, as you can see here, okay, in order to avoid blocking the user interface, we will run this this continuous polling loop inside of an asynchronous task. So this task will finish whenever we set the dashboard toggle to off. Okay, but it may happen that the user might close the window without toggling this control. So in order to avoid leaving this task running forever, what we will do is we add this line here that essentially will check if the client is still connected, and as soon as the client disconnects, we will break the loop. Okay, and this is it for this polling loop. We read the output from the ARM and we sleep for the refresh rate. Notice that we can have different rates. We can have the ARM update much faster than our dashboard, which is the case here. We update that dashboard once every 5 times per second, while the ARM it's updating much faster, but you are just polling it at this speed. Okay, and once we are done with once the dashboard has been turned off, once we exit the loop, okay, what we do is simply we set this variable that's bound to this handler to false. We do this with this suffix in order to avoid triggering the handler again. Okay, so we set it to false, and then the next time we click on the dashboard on toggle, we can set it back to true in order to trigger this handler again. Now this is can be a little complicated, I would say, but this is the nature of what we are doing here. We are running an asynchronous process in real time, so yeah, it can be a little more complicated than our let's say typical Genie app. And also some of you might be wondering why we are running this as 2 separate handlers, okay, instead of just one. Why aren't we running this loop, since it's depending on the dashboard on variable? Why aren't we running it inside of this handler, so that when we set this to true, this loop will start running inside of this handler? There's an explanation for this. I have added it here at the end. You can see our documentation for more information, but essentially the quick explanation is that in these handlers, and this is something that's important to know if you are going to do real-time applications, these variables are passed by value and not by reference. Okay, so if we were to have this loop here inside of this handler, we will always be checking on the same value. No matter what we do on the outside, we toggle, we update the value of the reactive variable, the loop will always see the same value because it's passed by reference. This only happens for this for the variables that are being watched by the handler. Any other reactive variable can be accessed to its actual value, but the one that's here, it will be by value. So that's why if we check on it from another handler, we can actually access its value. Again, this is something to keep in mind when dealing with this kind of real-time applications, and you can see more details here. And now that we have, I think we are done with the implementation, with all of the handlers and the entire process. Let's take a look at the finished tab. As you can see, I have just the uncommented code, and this is automatically reloading and should be working right away. So let me see if I turn on the dashboard. Okay, and as you can see, I can start playing with the controls and the dashboard runs. Notice that all this time the ARM has been running in the background, and this is still quite performant. And as you can see, I can change the PID controls in order to fine-tune the controller so that it tracks better the selected angle. And once we are done with the implementation, which we are, we have implemented everything we set out to do, would come the time for deploying the application. For deployments, you can use Julia Hub. So you can head over to juliahub.com. Let me open it in the browser. Here juliahub.com. Once you log in, you will see that the main view, and you can go to the projects view and create a new project. Once you have created it, you will need to upload your files. You can also use Genie Builder on Julia Hub as well instead of locally if you desire to do so. And once you are done with the development of your application, you just need to click this deploy button. And after a moment, after some minutes, you will have a URL, an internet address that you can share with anyone. And with this, I believe we have covered all of the content of this webinar. I hope it was useful for you. I hope that you will give Genie Builder a try. And I'm open to any questions from the audience if there is any.